Am I audible? Is my voice clear?
Not audible, sir. Hello, sir.
Not audible? Hello? Am I audible now?
Sir, not audible, sir.
Hello?
Sir, am I audible, sir?
Still? Yes, you are audible. You are audible. You are audible to me. Am I audible? Hello?
Sir, you are not audible, sir. Hello, sir. Sound also, sir.
Am I audible now?
Uh, Mute option.
Hello?
Sound
Am I
is
audible now?
sir. Hello, sir.
Yes, now. Am I audible?
Yes, sir. Now you're audible, sir. Now you're audible. Now you're audible, sir.
Is the voice clear now?
Yes, sir. Your voice is clear, sir.
Hello? Yes. Fine,
Yes, sir.
fine.
Your voice is clear,
Okay,
sir.
then let us start. Yeah, we are a little late today because of my scheduled classes already.
Yes, no issues.
See, today our next class will be from 7:30. Okay?
To 8:30, sir.
7:30 to 8:30. Yeah, next class will be from 7:30 to 8:30. Okay, this will be till 7, and then from 7:30 to 8:30 we'll have another class, because 7 to 7:30 my another class is scheduled. I have to take it anytime in between, but I could not manage it. Okay, so okay, then we will manage. So today we are just 10 minutes
Sir,
late. Okay, now yes.
sir, one class is from 6 to 7, another is from 7:30 to 8:30, sir. That's
Yes, yes, it's
yes, sir.
fine. Yes, now. Still, which point we have revised yesterday?
So we are discussing about accelerations.
Acceleration.
Some problems. Yes, sir. We need to we are discussing that equations of motions.
Equations of motion we were seeing. Now, derivation of equations of motion. Did we see that?
So, so we are
Yes, did we
discussing
see
the
the derivations?
derivation. Sir, no,
We
sir. We are
didn't see.
discussing it, sir. We
We were
didn't. We are
discussing it.
discussing
Okay,
it.
now.
The derivation.
So,
Yes, sir.
fine, fine. So, there are three equations of motion. And all of these equations of motion, actually, and in some books, you will find four equations of motion instead of three. Okay, why is it so? We'll see that later. Now, equations of motion can only be used when acceleration is constant. When the acceleration is not constant, in that case we cannot use the equations of motion. When the acceleration is not constant, then we cannot use the equation of motion. Then we have to use differential equations, which we'll see later. Now the three equations of motion are v equals to u plus at, s is equals to ut plus half at square, and v square equals to u square plus 2as. Just hold for a minute. Fine, fine. So, equation of motion, how do we derive it? We just use the definition of acceleration. Acceleration is dv by dt. dv by dt, or we can say rate of change of velocity, is it not? So, what we do, we just put acceleration on the side of dt and then we integrate. Then we integrate with respect to dt. These are different. Okay. Since we need to find the relation between initial and final velocity, okay, we will take initial velocity at t equal to 0 to be u, and final velocity at some t equal to t be v. Now integrating for the required limits means from initial velocity to final velocity, we are integrating this a dt. Thus integrating, we get what? Integrating, we get upper limit minus lower limit. Integration of dv is v. Put the upper limit, then subtract lower limit. V minus u equals to at we will get. Okay.
Yes, sir. Okay, sir.
Got it now? Now for second equation of motion, what do we use? For second equation of motion, we use again v equals to ds by dt. Definition of velocity we use. For second equation of motion, we use definition of velocity. Now from here, s ds is equals to v dt, or s is equals to integration of v dt. Instead of v, using first equation of motion, what we do, we substitute v equals to u plus at. Okay, and then we integrate it for the required limits. Integrating for the required limits for 0 to s and 0 to t, we get this equation s is equals to ut plus half at square. Got it now? Anything you need to write down, or shall we move ahead?
ఏమన్నా యాడ్ చేసిండేనా? అవునా? ఒక్కటి మిస్ అయింది. అదే వర్క్ లాస్ట్‌లో అదే మిస్ అయింది. సిలబస్ కంప్లీషన్ ఏమో ఇది Yes, sir, I'm right.
Okay, fine.
Yes, sir.
Okay, so next is third equation of motion. Third equation of motion, we use acceleration is equals to v dv by dx. See, all these formulas of acceleration we have seen already. Now we are using them differently. Acceleration is v dv by dx. So a dx equals to v dv. We just cross multiplied dx with a, and v dv is remaining on the other side. Now if we assume that at t equal to 0, the particle was at origin, means x equal to 0, and at t equal to t, it is covering a displacement s. Then integrating for the required limits means for completing 0 to s distance, and from initial to final velocity v, initial velocity u to final velocity v, we will get this. Acceleration is equals to, sorry, a into x to upper limit s and lower limit 0, v square by 2 upper limit v, lower limit u. Getting it now? Thus,
Yes, sir, getting,
we
sir.
will take 1 by 2 common, 1 by 2 we will take common, and that 2 will be multiplied on the other side of equality to the as. Hence, we are getting v square minus u square equal to 2as. This is our third equation of motion. This is our third equation of motion. Okay. Yes. Do you want to write down something?
Sir,
Hello,
nothing, sir. I
Hemant?
copied, sir. Sir, copied, sir.
Fine. Shall we move ahead?
Yes, sir, we can move, sir.
Fine. So see this example. A car starts from rest and accelerates uniformly for 20 seconds to a velocity of 72 km per hour. It then runs at constant velocity and finally brought to rest in 200 meters with a constant retardation. The total distance covered is 600 meters. Find the acceleration, retardation, and the total time taken. Yes, solve it now.
ఏం పెడుతున్నావు? ఎక్స్‌ప్లనేషన్ పెడుతున్నాను. బ్లైండ్‌గా డిలీట్ చేస్తున్నా అంటే ఎందుకు చెప్పాలి?
-1 and
-1
the distance will be
time is 20. 200 meter and time is
200
20.
meters. Yes,
And
time, no,
time
no,
is 20
time is
seconds.
10 seconds. 10, 10, 10. Time is 10 seconds. How? When distance is 200, distance divided by speed. Velocity is constant, isn't it?
Yes, sir.
So time taken will be distance divided by speed. That is 200 divided by 20. We will get 10 as our answer. Got it?
So got it, sir. Yes, sir.
Retardation is -1.
ఇన్నైతే ఉండవు కదా.
Similarly, this question, find out the distance traveled by the block in 10 seconds. Find out the distance traveled by the block in 10 seconds. Only this diagram is given in the question. In this diagram, u is equals to 10 meter per second in the right hand side and acceleration was -2. It means acceleration was in opposite direction. Acceleration was in opposite direction. Okay. So it means what? What will happen? The block will continue to move towards right for some time till its velocity becomes 0 due to retardation. Then it will start coming back because the acceleration is still negative. It will pull the block towards the left hand side. Okay? Getting my point?
Yes, sir, I'm
Hello?
getting, sir.
Fine.
Sir, I'm getting, sir.
So again, fine. So which equation to use here? We will use first equation. From first equation, we will calculate the time here. Okay. And then we'll put second equation so that we will get the total displacement. Got it now? And what we have to calculate here? We need to find out the distance traveled by the block in 10 seconds. So actually in 5 seconds, its velocity is becoming 0 and it is covering a displacement of 25 meters. Then in next 5 seconds, it will again cover the same distance because it will start coming back. It will cover again 25 meters and displacement because of that will be 0, but distance traveled will be 50 meters. Okay. Now see this question. A car covers 2/5 of the distance with the speed v1 and 3/5 of the distance with the speed v2. Find out the average speed. Yes, please try it out. Yes, try it out. You have 3 minutes, Hemant.
Yes, sir, I'm trying.
Yes, now. Similarly, see this example. A bus starts from rest with a constant acceleration of 5 meter per second. At the same time, a car is traveling with constant velocity of 50 meter per second. It overtakes and passes the bus. Find out at what distance will the bus overtake the car and how fast will the bus be traveling then. Just how to solve it. Tell me just how to solve it.
Yes, sir. A bus starts from rest with constant acceleration. It's now simply a car traveling with a constant velocity of 2 find out what is a bus. So we can use S relative motion concept here.
Hmm. Okay.
Find out
Then
what distance. So by using S relative, we can find the at what
just wait a minute.
time it.
Just wait a minute. Solve it. Try solving
Yes,
it.
sir.
Just wait a minute.
Yes, sir. Okay.
Hello. What do you mean by acceleration? Speed of a bus will go on
Changing.
increasing,
Yes, sir. Go on.
increasing. Acceleration is written. It means what? Acceleration. Whenever acceleration is written, we will take it as positive
Okay.
acceleration. Unless they are mentioning it as retardation, we will take it as positive acceleration only. So bus will increase. Its speed. It's obvious because bus is starting. It cannot have a retardation now. Its speed was already zero. How can it have retardation? It's not going backwards. Its speed is increasing. Okay,
Yes, sir.
because it is starting. So bus is starting with a constant acceleration. It means its speed is going to increase. At the same time, a car which was traveling with a fast speed, mean at 50 meter per second, it travels past the bus. It overtakes the bus suddenly. At the instant the bus starts. Car at 50 meter per second, it overtakes the bus and it moves ahead. Now what will happen? Now the bus will start. Its speed will increase from 0 to 1 to 2 to 3. It will take some time to achieve the speed which is equal to that of car. How much time it will take? It will take some time, obviously. We can calculate that separately. After that time, what will happen? After that time, the distance between car and bus will start decreasing. Can you imagine?
Yes, sir.
Means
I can
this
imagine.
was the bus. This was the bus. Suddenly, car came by and starts moving. Okay. Now, speed of bus will increase. Car will reach at some point ahead. This is the this is
Yes.
the car,
ఎందుకు
and
జొమాటో చేసింటే మా నాట్
let
పాలసీ
us
అని
say
చెప్పి
this
అంతే
is
కదా
bus.
మేనేజర్ కూడా తెలియ మేనేజర్
Okay,
మేనేజర్
bus is starting from zero, but car had an speed of 50 meter per second. Okay, so after some time, bus will reach this point, but car will reach this point. After some time, car will reach this point, but the bus will reach this point. The speed of bus is increasing from 1, 2, 3. Till what time the distance between both of them? will increase. It will increase till both of them achieves the same velocity. See, if you want to overtake a vehicle which is ahead of you, you need to have a speed which is greater than that of the vehicle. Getting my point? Hello?
Yes, sir,
Yes,
I'm
Hemant,
getting,
am
sir.
I audible?
Yes, sir, I'm your
For
audible, sir. I'm getting, sir.
overtaking, for overtaking a vehicle, you need to have a speed which is greater than that vehicle. If the vehicle is going at 50, then you must have a velocity of 60 or even 52 to get that vehicle to get passed by it. But if your velocities are equal, it means your velocity is 50 meter per second, his velocity is also 50 meter per second. He is covering 50 meters and you are also covering 50 meters. Whatever the distance is there in between you two, it is never going to decrease because you are covering 50 meters only in 1 second and he is also covering 50 meters. So the distance will remain same and you will never overtake. You will never be able to overtake that vehicle ahead of you. So similarly, similar case is there with this bus. It is never going to overtake if its velocity is below 50. Its velocity must be greater than 50, not even equal to 50. Its velocity must be greater than 50. So what we can do? We will say that let us assume at some distance s from the starting point bus overtakes the car and let that time be t. Therefore, in how much distance that bus will overtake, we will get an equation. We got an equation s is equals to 5 by 2 t square. Now in same time for overtaking, remember that for overtaking the two buses or the two vehicles must be at the same point at the same instant of time. Only then they can overtake, is it not? It means the
Yes,
distance
sir.
covered by car in the time t must be equal to the distance covered by the bus in the same time t. Okay, so from here we are getting an equation s is equals to 5 by 2 t square. And similarly for car, speed of car is constant, so we are going to use speed is equals to distance upon time. Okay, so 50 is equals to s upon t. 50 is equals to s upon t. S is equals to 50t. From both these equations, we are getting what? 10t, 50t equals to 5 by 2t square. Now cancel each and everything. We will get t equals to 20 seconds as our answer. T equals to 20 seconds we will get as our answer. Now when t equals to 20 seconds, then how much distance will be covered? How much distance will be covered by the car in 20 seconds? Multiply its speed by time. We are getting 1000 meters. It means 1 kilometer. 1 kilometer distance will be required for what? 1 kilometer distance will be required for the car to overtake the bus. Or for the bus to overtake the car. Got it now?
Yes, sir, got it, sir.
Want to write it down?
Sir, I copied,
Yes,
sir.
do you want to? You copied it? Fine. Similarly for second part was what? Second part was how fast will the bus be running then? Means at that time what will be the speed of bus? For the speed of bus we have what? V equal to u plus at. That's it. So apply v equal to u plus at. U was 0, a is 5, t is 20 seconds. It means what? 100 meter per second will be our answer. Got it?
Yes, sir, got it, sir.
Fine. Now, if the acceleration is not uniform, if the acceleration is not uniform, then what to do? then in that case we cannot use the equation of motion. In that case we cannot use the equation of motion. What to use then? In that case we will use the equation of differentiation. We will use the differential format of the equations of motion. Fine.
Yes, sir. Fine, sir.
So these are the equations of motion for differential format. For example, this is there. The position x of a particle is varying with time t. Equation is given to you as x equals to atq minus btq. Then in that case, at what time the acceleration of the particle will be 0? At what time the acceleration of particle will be 0? So what to do here? Here we will differentiate x twice and then we will get acceleration. Just equate it to 0 and get time. Can you do it?
Yes, sir. I can do so.
Yes, do it then. You will get
So we
3
get
at square.
a t square minus 3 bt.
3bt square. So 3t square taken common, it will become 3t square a minus b. Okay, so this is the velocity. If you differentiate the velocity, then you will get the acceleration. So
Yes, sir.
acceleration we are getting 60 into a minus b. 60 into a minus b.
Yeah.
And we need to find out at what time the acceleration of the particle is 0. Getting it? Now this is the acceleration. Equate it with 0. Equate it with 0. What you will get when the acceleration of the particle is 0? The acceleration of particle is 0 at t equals to 0. 60 into
Yes, sir. At
a
starting
minus
point, at
b, it should be equal to 0. It means what? T should be equal to 0 or a minus b is equal to 0. So at t equal to 0, acceleration will be 0. Got it now?
yes, sir, got it, sir. Sir, here they're given that the position vector no, sir, in the question.
Position vector, no. Position vector is not given. Here only x is given
I mean,
in terms of
cannot tell
time
me.
t.
Sir, so means here position is
Position
given with
vector
respect
will
to
be,
time.
yes, position is given with respect to time and position is only of x.
Sir,
Position is given with respect
sir,
to
means,
time. It yes.
sir, means here
So
we, sir, means here we need to assume the particle is starting from x equals to 0 only. So from origin it is starting, we need to assume, sir.
uh, no. We need not to assume anything uh, because particle is it is only acceleration is asked us. Only acceleration is asked here, and acceleration we are going to calculate instantaneous only. We are going to differentiate it twice, and we will get instantaneous acceleration. So it doesn't matter that particle is starting from origin or somewhere other than the origin. Got it? So we need to just differentiate it twice and we'll get our answer.
Yes, sir.
Fine. Now, see again this question. If the displacement is given by this, then find the acceleration at t equals to 10 seconds. At t equals to, if the displacement is given by this, then find the acceleration at t equal to 10 seconds. How to do it?
This is very important.
Again, you need to just differentiate it and you will get the displacement. Sorry, you will get the velocity, differentiation of displacement, and then acceleration at t equal to 10 seconds. Again, differentiate it. You'll get the acceleration at 10 seconds. Okay?
Yes, sir. Okay, sir. చూసినాడు ఏం మాట్లాడిందా చూసిన అన్ని చూసినాడు చూసినాడు అయితే
Just wait for a while. You
taking my
got this
freedom.
question? Got the answer of this question?
yes sir I got sir understood
Fine. Now the next question is, if the initial velocity of an object is u and its acceleration is a, then find out the displacement covered by it in nth second. See, this question is very good question, and in this question, whatever answer you will get, that answer will be our fourth equation of motion. That answer will be our fourth equation of motion. So I want you to try it out. Okay,
yes sir okay
try it out and tell me that whether you, whatever you get, that will be our fourth equation of motion, and we will see it tomorrow. See, now right now I am sending you some pics over WhatsApp for
yes sir
advanced, for preparation of advance. Okay,
yes sir okay
kinematics. Okay, fine. So this is from motion module. Motion is a coaching in quota. It's module of physics is very good one. So right now I'll be sending this questions from this module.
yes sir okay
This is of J main. Fine then, that's all for this class. Okay, multiple correct questions for JE Advance. I'm sending you. They are, how many questions are they? Fine. Okay, fine. Some questions are there. All of the questions you need not to do. I will specify which questions to do. Okay, over WhatsApp. And have you taken down this
yes
question?
sir
Fine
yes
then.
sir I have copied so
We
this
will.
yes
Yeah, fine. So try it out, and we will see it tomorrow. Okay.
yes sir okay sir
Fine. Thank you. Then you may leave now.
so thank you sir yes
Fine. Our next class will be on 7:30.
yes sir okay sir